Hi everyone and welcome to this tutorial. Here we are given the question x plus 2 multiplied to x plus p, giving us this quadratic expression here, x squared plus qx minus 10, and we're asked to find the values of p and q. Now x plus 2 multiplied to x plus p, we can see that these are two linear factors and we expect their product to be a quadratic, because the highest power or the leading term is going to be in x squared. Okay, so now let's start by opening out those two brackets. Opening out these two brackets, we take x multiplied to x and x multiplied to p. All right, so x multiplied to x is x squared, x multiplied to p is xp. Now we do the same thing with 2. 2 multiplied to x and 2 multiplied to p. 2 times x is 2x. 2 times p is 2p. Now that gives us x squared. And then we bring the terms in x together. We have x here, we have x here. So x is common. We factorize out x like that. And then plus 2p. Now we are told that this product gives us x squared plus qx minus 10. So let us write it out as a single equation. So we are told that x squared plus x into p plus 2 plus 2p gives us x squared plus qx minus 10. Okay. At this point, we have this quadratic, the left hand side is a quadratic, equal to the right hand side, which is also a quadratic. So we have the equality of two quadratics. Quadratic because the leading term has the power 2. The leading term has the power 2. Okay. The condition for the equality of two polynomials in general is that respective coefficients must be equal. Okay, so let's take the leading term. The coefficient here of x squared here is 1, and the coefficient of x squared there is also 1. So there we have perfect equality. Now let's go to the x term. The x term here and the x term. Okay, so we have x term here, we have x into p plus 2. We equate it to the x term there, cure x. Okay, for this to be equal, the coefficient here must be equal to the coefficient there. So that means that p plus 2 must be equal to q. Okay, so we can call that equation 1. Now we go to the constants, the term that do not carry the variable. Remember our variable is x. So we take the constant term. The constant term on the left hand side is, so we say also, the constant term on the left hand side is 2p. We equate it to the constant term on the right hand side. That means 2p is equal to negative 10. On the right hand side, this is the constant term, the term that does not carry x. All right? Okay, so from this can be called equation 2. So from equation 2, if we divide both sides by 2, we are going to have p is equal to negative 5. P is equal to negative 5. All right, so putting now p equals negative 5 in equation 1, we obtain, this is equation 1, so we now obtain negative 5 plus 2 to give us q. That therefore means that q is negative 3. Okay, so p is negative 5 and q is negative 3. That are the values of p and q when this linear factor multiplied to that linear factor equals this quadratic. We now go to the second question. Here we're asked to solve for x, given that x plus 1/3 all squared is equal to 4 all over 9. Now the temptation here is for someone to take square root of both sides. If we come here and say we take square root of both sides, then we are going to end up destroying one of the solutions. This is going to give us just one of the solutions. But if we look at it carefully, if this is expanded, if this expression here is expanded, we obtain a quadratic. And in the quadratic, we are supposed to have two solutions. A quadratic is supposed to have two solutions. So the better way or the best way to solve for x here is to bring the right hand side to the left hand side. Okay, so we have x plus 1/3 all of that squared minus 4 all over 9 equals 0. This is plus 4 all over 9. We'll take it to the left hand side, it becomes negative 4 all over 9. Now, looking at it carefully, we see that 4 all over 9 is actually a perfect square. And so let us write this expression here as a difference of squares. This is x plus 1/3 squared minus 2 all over 3 all of that squared. Okay. Now we will now use the difference of squares identities, which says a squared minus b squared gives us a minus b into a plus b. All right. This is the identity that we will use. Now, a here takes the place of x plus 1/3. B here takes the place of 2/3. So if we transform this into the right hand side of this identity, then we're going to have x plus 1/3 for A minus 2/3 for B. All right. All of that multiplied to x plus 1/3 for that A plus 2/3. Okay. Now, let's evaluate each side. We have here x plus 1/3 minus 2/3. 1/3 minus 2/3 gives us 1/3 minus 2/3 gives us negative 1/3. So we have x minus 1/3, and then we have here x plus 1/3 plus 2/3. 1/3 plus 2/3 is 1. So this will multiply to x plus 1. Remember, everything was equal to 0, equal to 0. So that from here now, if we have the product of two things giving us 0, then either x minus 1/3 is 0, in which case x is equal to 1/3, or the next one, x plus 1 is 0, in which case x is equal to negative 1. All right? So the two solutions for this equation are actually x equals to 1/3 and or x equals to negative 1.